return the entire linked list. So what they will ask you is to return the starting point. Then they will be traversing it on the backend. But they will ask you to return the starting point. Got this? So let's quickly get back into the code editor and write the code. I'll be writing the C++ code in case you're someone who is doing it in
हाँ मैं पढ़ रहे हैं। हम तो उठ के नाश्ता कर लिए थे, कितना 9 बजे 9:30 उठे हैं। हम तुम्हारा वो कर रहे थे कि हमको लगा तुम नहाने वहाने गई होगी। हाँ, तुम ही कर लिया करो, मेरे को लगता है तुम वो कुछ कर रही होती होगी। हाँ। और नाश्ता कुछ की? हम्म। हाँ, धूप बहुत निकला। हाँ हाँ, नहाएंगे नहाएंगे। ठीक है। ठीक। ओके बाय। हेलो 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 शिट।
Java, Python, JavaScript, doesn't matter. Understand the C++ code, because in the Java code there's a slight change, in the Python code there's a slight change, and I'll be showing you that. Don't worry about that. So what's this code? After that I'll be writing the Java code. Don't not worry. And in the links you'll be finding the Python and JavaScript code as well. So what do we need to do? We need to convert an array to a linked list. That's what we need to do. So we'll be taking a function which will be taking this array. What do we need to return? I told you we cannot return the entire linked list. So we technically return the head. What is head? We need a pointer to the head. That is what we will be returning, right? So can I say the head will always be the first element, which is array of 0. Since I have a multi constructor, I don't need to pass the null pointer. It will always be doing that for me. What is the next step? I need a mover which initially points to head. So the mover is standing at the first place. Perfect. Done. What's the next thing? Let's iterate. We skip the first element, which is the 0th index, and we go till the last. So let's go. What after this? We'll be creating a, like we'll be storing this value, stored in temporary. What is the next job? I need mover next because I need to create the link next to point to this temporary. And after that, I need to move because mover, if I go back over here, this temp was created. I had mover here. It pointed to this. After this, the mover has to go ahead. The mover has to go to front to the next one. So either you say mover go to your next, or you say mover equal to temp because it's the same thing. Because temporary is it. It's the same thing. So either you say mover equal to temp or you say mover equal to mover dot next. Same thing. Once you've done this, can I say everything is done? And you can straight away return the head. So imagine I say node head equal to convert, and I pass on this array, and then I try to print the heads data. You will see that it is converted. I'll also be telling you how to traverse, don't worry. If I try to print this, you see 2 is printed. If I just change it, make it 12, you'll also be seeing 12. Right? So, very simple. So let's quickly copy paste this and go back to the Java editor. Inside the class, so you can paste it. The first thing is remove 0 complexity. So array to linked list is done. What is the next thing? Traversal in linked list. Now this is very, very important because if you understand how to traverse in a linked list, you can literally do everything. So traversal is something that you will have to learn because even if you remember the array problems, you always traverse in an array. So similarly in linked list, in all the problems, you'll have to traverse through the entire linked list. How do we traverse? So once the array is converted to a linked list will look something like this. Again, it will be somewhere in random memory space. We will always have the head. And what is the head pointing to? The head of the linked list, the starting of the linked list. And as I said you, never ever tamper the head. That's the first rule of linked list. Never ever tamper the head, because if you move the head from here to here, you forget which is the starting point. Who will remember it? So never ever tamper the head. The first thing I'll do is I will take a temporary variable which is also at head. Tell me, what do I need to print? 2. How can I print this? That's basically temp of data. If I do this, it'll give me the value 2. Correct? But after that, I need 3. How do I get 3? I'll have to take this temp to here. How can I take this? We have the next stored. Just go to the next. After that, I'll have to take take 1. The starting point. Who will remember it? So never ever tamper the head. The first thing I'll do is I will take a temporary variable which is also at head. Tell me, what do I need to print? 2. How can I print this? That's basically temp of data. If I do this, it'll give me the value 2. Correct? But after that, I need 3. How do I get 3? I have to take this temp to here. How can I take this? We have the next stored. Just go to the next. After that, I'll have to take 1. Again, go to the next. After that, I'll have 8. Again, go to the next. After that, the temp will reach at the moment null. The moment it reaches null, you stop. So can I say, if I have to implement this, it's probably I'll just take the code editor and write it. It's going to be super simple. Node start temp head, because I don't want to tamper my head. Node start temp equal to head, while temp not equal to null. Or maybe you can just say while it is valid. After this, cout temp data and this. And then temp will move to the next. So let's move to the next. Let's try to play it. So if I, yeah, The entire array is printed. Done. If I have to show you in Java, now printed. Done. If I have to show you in Java, now you will appreciate me that, hey, it's very, very easy. So just take this instead of this. I'll just say temp.data and probably do a plus this, and instead of this, I'll write this and I'll just take this. And while this is not equal to null because in Java, okay, perfect. Let's try to. Should be easy. The C++ Java codes are same. So you don't have to think about it. So next one, length of a linked list. How can you find the length of a linked list? Imagine you're given a linked list and you'll have to find out a length. Can I say private or maybe length of LL? And always you'll be given the head. So node star head will be given to you. What do? You take a counter 0, you copy paste the traversal. Yes, you just copy paste the traversal. And inside the traversal, you give a counter plus plus and you can return the count. That's it. That's how you print the length. So if I have to print the length, I can simply say cout length of the linked list. Oh my bad. Length of the linked list and head, and I can go ahead and run this. Finally, yeah, should be good. I don't need to print this. I can omit this off, and if I print this, the length is 4. Perfect. Super simple. Again, Java SG and the link. Head, remove this, and if I print this, the length is 4. Perfect. Super simple. Again, Java. SD need Java code now. Isn't it easy? This, remove this, do this, do this, done. Is it that tough? Okay, let's take system.out. Otherwise, I'll have to write this. And the linked list head should be good. Should be good, right? Let's run it. My bad. Let's run it now. 4 done. Quite simple. I just removed 2 things. Java code also runs. So let's take the same code and we'll go to the code studio and copy paste here and try to submit it. Let's see if one time submission works. It will. So it's pretty easy, isn't it? So the length of a linked list is done. It will be taking a big O of n time complexity. The next thing, search in a linked list. I think most of you can do it. So what is the question? Given a linked list. So whenever it is said that you're given a linked list, you'll always be given the head of the linked list. And given an element, tell me if that element exists in a linked list or not. So search or check if present. So you'll be given, yes, you'll be given the head and you'll be given the value that you have to check for. One thing is for sure, you always copy paste the traversal. So please copy paste the traversal. Never ever tamper the head. So how do I check? Can I say at any moment if temp dot data equal to val, I return yes, which is 1, or else I return 0 at the end if the entire traversal is complete. Quite simple. Can I write this? Probably I'll just remove this and I'll say this check if present, and I'll probably pass on the head and I'll ask them to check for S5 there. And I'll copy paste in this. It's slightly different. It's saying the type name. The template is similar. It'll just be given the function. You'll not be given this int main or these things. You'll have to understand. So over here, I'll pass on the head and I'll ask them to check for S5 there. Let's see. Let's try one. Oh, yeah, it is there. Let's say 15 is there. Now it's not there. So this is running. So the next thing I'll do is I'll take this code and I'll copy paste in Code Studio. Why am I running in Code Studio? Because the environment in your coding rounds or your online assessments will be similar. It'll just be given the function. You'll not be given this int main or these things. You'll have to understand. So over here, you are seeing that it's slightly different. It's saying the type name. The template is slightly different. So whenever there is something like t, which means you define it, it can be integer, it can be double. Like over here, they're defining it that it will be integer. So this is how you write a like global template that can be reused for anything. Like if I write it as int, I can only use it for int, but if I write it for t, I can use it for string, arrays, anything. This is how you write it. Got it? So if you run this, this will not run. You'll have to specify over here like this. Yes, you'll have to specify over here, otherwise it will not run. And this is k, so let's do it k and try to submit it straight away. So these are the things, that is why I'm using compilers, something which are similar to online assessment, so that you understand how the questions will be asked. What is the time complexity? Obviously, we go off n at the worst case in case the element is not found. We go off n at the best case in case the element is the head itself. And the average will be n by 2 in case it is somewhere in between or somewhere like that. So this is also done. So you're still left with deletion and insertion. We'll be doing that in the next lecture. In case you're still watching, please do consider giving us a like. deletion is completed. Now, if you understood deletion in depth, this is going to be super simple. So let's try. Let's in a linked list, and the first variety is deletion of the head. So how does a linked list look like? Something like this, where you have a head which is pointing to the starting point of the linked list, and after that, it is pointing to the next. It is pointing to the next, and then it points to the null pointer. Right? This is what we have learned in the previous lecture. So the question is to delete the head of the linked list. So basically, this is something that you have to delete. That is the starting point. How can you delete it? You can say that, hey, in a linked list problem, we always store the head because that is where it starts. What if we move the head to the next? If we move the head to the next, so technically, the linked list will start from here. Can I say this? Technically, the linked list will start from here. Yes, but this node will still be there. The question was to delete it. The question was to delete it. So how can you delete it? Can I say, what if I keep something? By the way, we always write functions. Imagine we are writing a function which will be returning the new head. Delete head. Can I say it will be taking the head of the linked list? Perfect. How can I delete it? Maybe I'll keep the node a functions. What if I keep something? By the way, we always write functions. Imagine we are writing a function which will be returning the new head. Delete. Head. Can I say it'll be taking the head of the linked list? Perfect. How can I delete it? Maybe I'll keep the node temporary as head. Why do I do that? I'll tell you afterwards. So we'll keep it temporary, which is pointing to the starting. After that, what I'll do is I'll say head, can you move to the next? Head will move to the next. So it moves to the next. After this, so when you move head to next, what happens? This one. So if you go ahead and say, hey, return head, that's going to work because this function is expected to return the head of the new linked list, and the head of the new linked list is this. This is okay, and this will work correctly because the program now assumes this is the starting point and this is the entire linked list. This is still there. So you need to free this memory because this is still there in some part of the heap, right? So what you say is in C++, there is something as free, and you can call free temp. That is how you can free a head of the linked list. So you can either write free of temp, or you can go ahead and write delete temp. That will also work. This is in C++. In Java, this particular line is not required. You don't have to manually free that space because in Java, we have something as garbage collector. Remember the term? Garbage collector. So what happens is you don't write this, and this temporary is somewhere in the heap memory. Whenever the garbage collector will run, and it will see that there is no reference to this, like in the program, there is no reference to this one. It will delete it, and it might not be an immediate operation. It might happen sometime in the future, but you don't have to worry. Java takes care of it whenever there is a memory issue or whatever. It will take care of it. You do not have to do it. But in C++, it is something that you have to do it manually. So do it. But in C++, it is something that you have to do it. We need to write a function that returns the head after removing the head, right? So let's take the head as the function and let's name it as removes head. Imagine if the the linked list that is provided to you is empty. In that case, the starting point will always be null, isn't it? So you'll say, what if it is null? In that case, you'll return the same head saying, hey, I don't have any linked list. It is null itself. So that is why I'll return whatever you have given me. Something similar to what you did in arrays. Whenever you got an empty list, you always return that, hey, we can't do anything on the empty list. So this is the edge case that you'll write for all the linked list code. What's the next thing? We'll have to take the temporary equal to head, and then we'll have to say head equal to head dot next. Once I've said this, what's the next thing? Node star, or maybe I need the new head, so I can just replace the existing head with removes head. Is that the name? I'll just copy paste. Removes head with the head. This will remove it. After that, I need to print it. So I already have a function which prints my linked list over here by traversing. Now I'll try to run it and see if it is running fine. It does. It removes this head, and now the head is starting from 587. So what I'll do is I'll quickly take this code into the Java, and I'll write private static, copy paste it, remove this, remove this. This will be small, and remove this head.next. You don't have to delete it, so no need to store in temporary. Done. Once you're done this, call the head to be removes head, and then pass on the head. After this, call the print function, pass on the head, and let's see if it prints or not. It prints 568. Super simple. So in Java, you know the differences now. You don't have to free it. So this is how you can delete the head of the linked list. So we are done with head, and then pass all and remove this head.next. You don't have to delete it. So call the after the differences now. You don't have to free it. The head, and let's try to do the tail of the linked list. Delete the tail of the linked list. So if I go back to the linked list, the head is pointing to the starting position of the linked list. And can I say that the tail is this? So once you've removed this should be pointing to a null pointer. How do I remove it? Can I surely say if I'm able to stop before, again I repeat, if I'm able to stop before the last element, in that case, I can say this one, let's assume this is a temporary element. I can say this temporary to point to null. I can say this temporary to point to null. Can I say this? I can. So what I need to do is I need to stop before the last element. I need to stop before the last element. So if I'm stopping before the last element, what does that mean? The linked list in minimum has two elements. Then only I can stop before the last. If we had a linked list which is simply like this, if we had this one element linked list, can I stop before the last? No. In that case, I'll have to to delete this because it's a linked list with one element. So can I say for linked list with one element, because that one element will be the head, that one element will be the tail. So I delete that one element. So I delete that one element. So what will be the case? Let's quickly write down the function. Again, I'll write node star delete. This time I'll write delete tail. And I'll take the head. After deletion, you have to return the head of the linked list. So can I say the first thing that I'll do is, obviously the first case, what if it is null itself? If it is null itself, then I'll return null. And because if it is empty, I return whatever I've been given to. Or if the head dot next, if the head dot next is null, what does that mean? This means either the linked list is empty, this means it only has one element and the next is pointing to null. In both the cases, I'll return null because if I delete one element, there will be no linked list. So what I'll say is, in both the cases, I will be returning null. That means I don't have anything. The linked list is gone. That's what I'll return. What is the next thing? Apart from this, the link Linked list always has a minimum of two elements. So I'll have to stop at the second last element. I'll have to stop at the second last element. Dot next. If I write, imagine this is temporary. If I write temporary dot next, where does it point to? It points to null. It points to null. I'm standing at the second last element and I'm saying temporary dot next, which means last, and then that's next, which means null. So you're saying dot next, dot next. So what I will write is, hey, listen, while temporary dot next and dot next. If that's not null, I will keep on going. I will keep on going. Or else I'll stop. So what happens is, you keep on going. I'll show you how it goes. It's very simple. What happens is, you initialize the temporary to head. So maybe initialize it here, node star temp head. Why do we do it? Because we don't want to alter the head. We don't want to do anything to the head. We need to preserve the head, because that is what we have to return. We have to return the head of the linked list. So we cannot alter that. So we preserve it. That's why we put it into one more. We take a copy of it, and then we do whatever we want to do with the copy. So the temp is standing here. What will happen? At first, temp.next, is it null? Is it null? No, it is not. So what will happen? I'll say, temp, can you move to your next? Temp, can you move to your next? He says, happily. I'll move to the next. Perfect. I move to the next. What is the next check? I say again, temp.next, that is what it checks. Dot next, is it null? No, it's free. Again, move temp.next. Let's move. So I take temp here. What is the next job? Temp.next, dot next. That is the check. Is that null? Yes, that is null. So the while loop is done. I don't move. And once the while loop completes, the temp is standing at the second last element. The temp is standing at the second last element. What do I need to do? I need to remove the tail. So can I say, I'll simply point this to null, and that will be removed. But this is an element. I need to free it. So what I'll do is, in C++, I will say free temp.next. Why? Because I know what is temp.next. Temp.next is 3. I'll free it. I'll delete it. In Java, you don't have to. Garbage collector will do it for you. And then you'll say, hey, temp, your next now can point to null pointer. That's what you can say. Your next can point to null pointer. And once you have done this, what will happen? This will point to null pointer. This will point to null pointer. Done. Everything is done. Now you simply return the head, because in every question you'll be returning the head of the modified linked list. So you return the head, and that is how the program will look like. Simple. Let's quickly get back into the code editor. I'll remove this because I want to remove the tail. I'll write node star, remove tail. I'll take a head of the linked list, and it'll also return the head of the linked list. So the last statement will always be this. What's the first thing? If the linked list is empty, so kindly check for it. That's this statement. Or if it's a single element, which is this. In both the cases, I can go ahead and return null. Quite simple. Or else I say node star temp equal to head. I store a temporary, and I say temp dot next, and the next is equal to null. In that case, sorry, not equal to null. In that case, keep on moving because it is not the last element. That is what you do. After this, temp will be standing at the second last. So you need to delete the last, right? So maybe what you can do is you can say delete temp. So the last one is deleted. After this, you say the next, my bad, temp dot next should be pointing to null pointer. And once you've done this, you can straight away return this. I think this should be running fine. Let's quickly check it off. So what I'll do is I'll remove the tail, and I'll pass on this head, and I'll replace this head. So this is the head of the new linked list. I'll remove the tail, and I've asked it to print. So basically 7 should be removed. Let's see if it is working. It is working. If you carefully see, I remove the tail and then I'm printing it. In order to check it, what I'll do is I'll take this code. So in order to check this, what I'll do is I'll copy paste this code, and I'll go to UX, which will be very similar in your online coding rounds, because this is all you will be getting. You'll not be getting this into me. That's it. And so I'll quickly submit this. Maybe I can straight away submit because I'm confident it has run. So going back, let's convert this into Java. Again, let's quickly copy paste this, the same thing. Let's write private, static, done. Let's remove this. Let's make it this. Let's do it null. Let's convert it to null. Let's remove the star. Let's return null. Let's remove the star. Instead of this, let's write this. Instead of this, let's write this. Instead of this, write this. This will be dot. This will, okay, we don't need to do this. We can just point it to the next. Yes. So instead of this, let's remove the tail and let's not try to run. I think it should be good. Yeah. Removes it. As you, the logic stays the same. We just remove something and it starts working. So this is how you can remove the tail from a linked list or delete. Going back, let's convert this into Java. Again, let's quickly copy paste this, the same thing. Let's write private, static, done. Let's remove this. Let's make it this. Let's do it null. Let's convert it to null. Let's remove the star. Let's return null. Let's remove the star. Instead of this, let's write this. Instead of this, let's write this. Instead of this, write this. This will be dot. This will, okay, we don't need to do this. We can just point it to the next null. That should be okay. So let's point it to null. Done. Yes. So instead of this, let's remove the tail and let's not try to run. I think it should be good. Yeah. Removes it. As you, the logic stays the same. We just remove something and it starts working. So this is how you can remove the tail from a linked list or delete the tail of the linked list. So this one is done. Let's try out this one. Over here, you'll be given k. So you'll have to complete the kth element of the list. What does it mean? Imagine He is given a slide. And the length of the list is remove the tail from a linked list or delete the tail of the linked list. So this one is done. Let's try out this one. Over here, you'll be given and star, convert it to null. Let's remove the star. Let's return null. Let's remove the star. Instead of this, let's write this. Instead of this, let's write this. Instead of this, let's write this. This will be dot. This will, okay, we don't need to do this. We can just point it to the next null. That should be okay. So let's point it to null. Done. Yes. So instead of this, let's remove the tail and let's now try to run. I think it should be good. Yeah, removes it. As you, the logic stays the same. We just remove something and it starts working. So this is how you can remove the tail from a linked list or delete the tail of the linked list. So this one is done. Let's try out this one. Over here, you'll be given K. So you'll have to delete the kth element of the list. What does it mean? Imagine k is given as 5 and the length of the list is four. So in that case, you'll not be deleting anything because this value exceeds that one. So you'll not be deleting anything. Let's check out the next thing. What if k is 1? one. In that, try out from a linked list or delete the tail of the linked list. So this one is done. Let's try out this one. Over here, you'll be given k. So you'll have to delete the kth element of the list. What does it mean? Imagine k is given as 5 and the length of the list is 4. So in that case, you'll not be deleting anything because this value exceeds that one. So you'll not be deleting anything. Let's check out the next thing. What if k is 1? In that case, we boil down to the first problem, that is deleting the head. What if k is given as 4? In that case, we boil down to the problem where we delete the tail of the linked list. What if k is given as 2? What if k is given as 3? In that case, you boil down to the problem where you delete any of the middle nodes in the linked list. So you'll have to write an algorithm that deletes maybe the head, maybe the tail, maybe any other node, or maybe nothing. You'll have to combine all of them into one. And what you'll be given is the kth element, basically second element, or the third element, or the fourth element. That is what you'll be given. How can I think of it? So always in linked list problems, you start thinking of edge cases and then you build on it. Never ever try to think of the algorithm. What can be the minimal thing that I can think of? First thing that I can definitely think of is, what if k is 1, which means I've been asked to delete the first element in the list. In that case, we straight away delete it. So can I say, while I start, let's try to write the code and slowly we'll try to improvise. So again, we'll be returning the head of the linked list. So node delete k, and it'll be given the head of the linked list definitely, and it'll also be given the k. So can I say one thing for sure? What if the list is empty? That's always our edge case. If the list is empty by any chance, we do not do anything and we return whatever head is given to us. That is the edge case that you'll write every time. After that, let's try things. So I've written down the basic edge case. Let's try to think about the next edge case. What if k is 1? In that case, it is always the head of the linked list that I have to delete. So can I write something as, hey, if k is 1, in that case, you'll have to Implement a logic. What will be the logic? You'll have to move head here because that is the new head of the linked list. And at the same time, you'll have to delete this. So obviously, we need a reference of the previous one. So maybe let's remember the current head at first. So what we have done is we'll remember it. Then maybe let's move the head to the next. So head will move to the next. Over here, you can straight away return the head because this will be your head of the new linked list. You can straight away return it. Or what you can do is you can free this particular temp stating there's nothing, just free yourself. After that, you can go ahead and return the new head. So that's how you'll do it. In case you don't want to do the free step, this will go and this will go. You just move the head to the next and you return the head. So this is what will be done when K is 1. So I've written down the case for K is 1. What after that? What if I've been asked to delete, let's say, the third element, which is basically this? Let's quickly erase this at first. And
अगर जब हम ये सिद्धू कुमार गुड इवनिंग आप कॉम्प्लेक्सिटीज देखी थी तो एक लूप का प्रोग्राम रह गया था मेरे हिसाब से एक अच्छा प्रोग्राम था तो हम पहले वो कर लेंगे लूप का ठीक है वो लूप कॉम्प्लेक्सिटीज का देखेंगे फिर इसके बाद आगे बढ़ेंगे एक सिंपल प्रॉब्लम जो सॉल्व करेंगे यहाँ पर चलिए बच्चों देखेंगे कौन आंसर कर पाएगा इसका बोलिए व्हाट इज आंसर फॉर दिस थ्रेशोल्ड और टेस्ट इज नॉट एनी बेंचमार्क टू मेजर योर परफॉर्मेंस। छोड़ दीजिए, आप टेस्ट के ऊपर कॉन्सेंट्रेट ना कीजिए, लेक्चर्स के ऊपर कॉन्सेंट्रेट कीजिए, प्रॉब्लम सॉल्विंग जो हम क्लास में कर रहे हैं उसके ऊपर फोकस कीजिए, वो बेसिस पर पीवाईक्यूज फोकस कीजिए। टेस्ट सीरीज आखिरी में करिए आप। आई एम टेलिंग यू रिपीटेडली, डोंट गेट डिमोटिवेटेड विद टेस्ट। तो बिल्कुल आप, मैं ब्रेकअप कर रहा हूँ, देखिए ऐसे ब्रेकअप करेंगे हम। ये जो आउटर लूप है, ये जो आउटर लूप एग्जीक्यूट जो हो रहा है, ये इसके स्ट्रक्चर के बेसिस पे प्लीज मुझे बताइए बच्चों, जस्ट ब्रेकअप करके बताइए व्हाट इज ऑर्डर ऑफ मैग्नीट्यूड ऑफ दिस। खाली ये लूप का कॉम्प्लेक्सिटी क्या है आउटर लूप की। आउटर लूप रिपीट फॉर हाउ मेनी टाइम्स, बस इतना मुझे बता दीजिए। ये ऑलरेडी हमने कहा, जो हम प्रीवियस एग्जांपल देखे उस बेसिस पे देखे थे। दिस लूप की कॉम्प्लेक्सिटी जो है आई स्क्वायर की कॉम्प्लेक्सिटी, आई इज इक्वल टू आई स्क्वायर, हमने क्या कहा, बिल्कुल सही, बिल्कुल सही, सभी बच्चे सही जवाब दे रहे हैं। लॉग लॉग एन है जी, लॉग लॉग एन। चलिए, तो आउटर लूप रिपीट हो रहा है लॉग लॉग एन टाइम। चलिए नेक्स्ट दूसरे कलर से लिख लेंगे, तो वेरी करेक्ट, ये लॉग लॉग एन टाइम रिपीट हो रहा है। अब हमें इनर लूप्स के बारे में स्टडी करना है। इनर लूप का दोनों का ऐसा कंबाइन कर लेंगे, ऐसे कंबाइन कर लेंगे। ये भी अगर आप और करो, वी हैव ऑलरेडी डन दिस इसका, इफ यू रिमेंबर। क्या मुझे बताएगा, कोई बताएगा व्हाट इज द ऑर्डर ऑफ मैग्नीट्यूड ऑफ दीस टू नेस्टेड लूप्स? ये दोनों नेस्टेड लूप्स को डिपेंड है, डिपेंडेंसी है यहाँ पर, इसलिए मैं दोनों को कंबाइन किया हूं। क्यों डिपेंडेंसी है? बिकॉज ऑफ जे गेटिंग इन्वॉल्व हियर, जे यहाँ पे आ रहा है, जे यहाँ पर इनिशियलाइज है, तो इसलिए डिपेंडेंसी है। तो दोनों को कंबाइन करके हमें टाइम कॉम्प्लेक्सिटी निकालना है। अश्वनी सिंह, यस यू कैन अटेंड। आज से आप लाइव क्लासेस अटेंड कीजिए, नई स्ट्रैटेजी स्टार्ट हो रही है, बिल्कुल आप फॉलो कर सकते हो, आराम से फॉलो कर सकते हो, आराम से कर सकते हो। चलिए बोलिए, व्हाट इज द ओवरऑल कॉम्प्लेक्सिटी ऑफ दीस टू लूप्स पुट टुगेदर? ओवरऑल कॉम्प्लेक्सिटी क्या है? नहीं, इट इज नॉट एन स्क्वायर, गौतम गांधी। इसलिए मैं कह रहा हूं, यू फोकस ऑन क्लासेस फर्स्ट रादर देन टेस्ट सीरीज। टेस्ट सीरीज से, डीपीपी से आपको सब्जेक्ट नहीं मिलेगा। आपको वीडियो लेक्चर्स आप जितना मैक्सिमम वॉच करोगे, उससे आपको सब्जेक्ट मिलेगा। गौतम गांधी पर्टिकुलरली आई एम टेलिंग यू कि आपको डीपीपी टेस्ट सीरीज से सब्जेक्ट नहीं मिलेगा, आपको सब्जेक्ट मिलेगा वीडियो लेक्चर्स और प्रॉब्लम सॉल्विंग हम यहां पर जो कर रहे हैं उससे मिलेगा। चलिए, व्हाट इज द ऑर्डर ऑफ मैग्नीट्यूड ऑफ दिस? ये देखिए कैसे, फॉर i इज इक्वल टू 1 to n, राइट? अब ये डिपेंडेंसी है तो हम सेपरेटली इसको इवैल्यूएट नहीं कर सकते, इसके डिपेंडेंसी कैसे कर सकते? कैसे करेंगे? ऐसे करेंगे, देख लीजिएगा। जिन्हें अभी कंफ्यूजन है देख लीजिएगा। फॉर j इज इक्वल टू 1 क्या होगा? दिस फॉर लूप विल रिपीट फॉर k इज इक्वल टू k प्लस 1, मतलब n टाइम्स k विल रिपीट फॉर n टाइम्स, ठीक है ना? मैं सीक्वेंशियली कर रहा हूं, बिल्कुल ग्राउंड लेवल से कर रहा हूं। j इज इक्वल टू 1, दिस विल बी रिपीट फॉर n टाइम्स। फिर उसके बाद क्या होगा? j इज इक्वल टू 2, मतलब k इज इक्वल टू k प्लस 2। तो हमने कहा ऑलरेडी इट विल बी रिपीटिंग फॉर n by 2 टाइम्स। इसका एक जनरल फार्मूला, इफ यू रिमेंबर, आई हैव गिवन यू, इफ यू रिमेंबर द जनरल फार्मूला फॉर i इज इक्वल टू 1, i लेस देन और इक्वल टू n, i प्लस इक्वल टू a, i इज इक्वल टू i प्लस a। इसका जनरल फॉर्म में क्या कहा था? दिस विल रिपीट फॉर n by a टाइम्स। अगर वैल्यू ऑफ j 2 हो गई तो दिस विल रिपीट फॉर n by 2 टाइम्स. मतलब इन जनरल अगर आप बात करोगे, दिस लूप विल रिपीट फॉर n by j टाइम्स. n by j टाइम्स. n by 1 ये n by 1 है, प्लस n by 2 next it will repeat for n by 3 times, so on n by n times. n by n times ये n तक जा रहा है. Is it not? आपको ये रिपीट ऐड करना है. So this is nothing but n into sigma 1 by x going from 1 to n. और हमने ऑलरेडी कहा ये लॉग सीरीज है. This we have done already, this log series. तो इसकी ओवरऑल कॉम्प्लेक्सिटी बनेगी n log n. इसकी ओवरऑल कॉम्प्लेक्सिटी बनेगी n log n. सही है ना? बिल्कुल देखिए कितना स्मूथली किए हम. बिल्कुल अगर आप ये जनरल फार्मूला जैसा इसका यहाँ पे जनरल फार्मूला बोले, उसी तरह इसका अगर जनरल फार्मूला आप याद रखते तो आपको आंसर बिल्कुल आसानी से आ जाता. प्रखर सिंह, वाई n by j क्यों हुआ? मेरी पिछली क्लास देखिए, आप मेरा पिछला वीडियो देखिए. आई ऑलरेडी एक्सप्लेन टू यू व्हाई इज दिस n by j. यू वॉच माय लास्ट क्लास वीडियो. ये बेसिस पे हम डिराइव किए यहाँ पर. अगर हमारा लूप ऐसे होगा तो दिस विल एग्जीक्यूट n by a टाइम्स. ठीक है. राधे इज सेइंग राम राम एंड राम विल सेम राधे राधे. राइट, दैट्स राइट. ठीक है. तो दिस इज n log n. तो अब बताइए पूरों को कंबाइन करने के बाद ओवरऑल कॉम्प्लेक्सिटी क्या होगी? आउटर लूप इज रिपीटिंग फॉर log n. दीज इनर टू लूप्स इज रिपीटिंग फॉर n log n. सो n log n रिपीटिंग फॉर log n टाइम. n log n इज रिपीटिंग फॉर log n. मतलब ओवरऑल कॉम्प्लेक्सिटी, टोटल टाइम कॉम्प्लेक्सिटी t of n बनेगी आपकी राइट ऑर्डर ऑफ या ओमेगा ऑफ थीटा ऑफ log n आउटर लूप इनटू n log n इनटू n log n. ये होगी आपकी कॉम्प्लेक्सिटी. ये होगी आपकी कॉम्प्लेक्सिटी ऑफ दिस लूप. बोलिए क्लियर है ना? Those who have been attending my classes regularly can only understand. जो फर्स्ट टाइम अटेंड कर रहे हो वो अटेंड आप अंडरस्टैंड नहीं कर सकोगे, क्योंकि इसके डिवाइड एंड कॉन्कर हम जनरली अपने लाइफ में भी यूज करते हैं. देखेंगे डी एंड. मैंने पहले लेक्चर में कहा था कि फॉर सॉल्विंग अ प्रॉब्लम देयर कैन बी मल्टीपल अप्रोचेस. एक प्रॉब्लम को आप मल्टीपल वे से सॉल्व कर सकते हो, मल्टीपल अप्रोचेस से सॉल्व कर सकते हो. उसका बेस्ट एग्जांपल है जैसा फ्रॉम योर स्टडी के सॉर्टिंग है. सॉर्टिंग इज अ प्रॉब्लम. तो आपने देखा होगा कि कई सॉर्टिंग टेक्निक्स है. सिलेक्शन सॉर्ट है, बबल सॉर्ट है, हीप सॉर्ट है, मर्ज सॉर्ट है, क्विक सॉर्ट है. सभी सॉर्टिंग टेक्निक अपने अपने तौर से अपने अपने तरीके से सॉर्ट करते हैं. हर एक के अपने अपने अलग अलग मेथड्स है, अप्रोचेस है, लॉजिक है. तो उसी तरह ओवर ए पीरियड ऑफ ईयर्स, यू कैन से 150 to 200 ईयर्स, आज पिछले 150 to 200 ईयर्स से, राइट, 150 to 200 ईयर्स से पहले से जो डिफरेंट अप्रोचेस लोग जो यूज कर रहे थे, डेवलपर, डिजाइनर्स, इंप्लीमेंटर, रिसर्चर्स, तो एक सॉर्ट ऑफ स्टैंडर्डाइजेशन किया गया कि ठीक है भाई, दिस एक प्रॉब्लम को अगर हम इस तरीके से सॉल्व करेंगे तो इसका नाम ये होगा, अगर दूसरे तरीके से सॉल्व करेंगे तो इसका नाम ये होगा, ये भी एक ऐसे. तो दीज आर कॉल्ड स्ट्रैटेजीज और डिजाइन अप्रोचेस. उसमें वन ऑफ दी, हाँ, मर्जिंग का ठीक है, मर्ज सॉर्ट में आ जाएगा. आदर्श मिश्रा, होमवर्क था मर्जिंग का. मैं मर्ज सॉर्ट जब ये प्रॉब्लम मिलूंगा तो हम डिस्कस कर लेंगे, वहां पर आ जाएगा वो प्रॉब्लम. ठीक है ना? डोंट वरी, इट विल कम हियर. लेकिन फिर भी आप आंसर बता सकते हो. अगर इफ यू हैव वर्कड आउट, यू कैन टेल मी द आंसर नाउ. व्हाट इज द स्पेस कॉम्प्लेक्सिटी ऑफ दैट मर्जिंग प्रोसेस? या पार्थ चैट इज विजिबल. तो ऑर्डर ऑफ 2n ऑर्डर ऑफ n होगा. दैट्स आंसर है. बिल्कुल ऑर्डर ऑफ n बिल्कुल सही है. ऑर्डर ऑफ n, नो प्रॉब्लम. तो चलिए वापस आ जाइए. तो बच्चों सबसे पहली जो